Hello. Where's the camera at? There we are. Hey, we're working on 3.1 Part C today, the last section of the chain rule. However, the chain rule will never go away because that's going to be an integral piece of our entire calculus endeavor this year. So what are we doing today? We are going to calculate derivative of composite functions, and it is going to focus on graphs and tables. We're going to see a lot of graphs and tables, and we're going to get our data from those. This is kind of one of my favorites. I love doing these because you don't have a lot of computation to do. It's just looking up stuff and grabbing the data piece. So example 9, yes, we are in example 9. The values of two differentiable functions f and g along with their derivatives are given in the table below for several values of x. Yes, can you see the values of x right here? And then across the top, we see the functions. And then the body of the table, of course, contains the data. Given h of x equals f of g of x. When I see that, I immediately think composite function because I have f composed of g. And then it asks us to find h prime of 3. Well, what I would love for you to do, just give me some space, is to kind of lay out your game plan. My game plan is to say h prime of x equals derivative of the outer multiplied by the inside times derivative of the inside, right? That is the chain rule. H prime of, let's do 3 next. I want to find it at 3 would look like h prime of g of 3 times g prime of 3. Now for the table work. I am going to have a couple steps yet because I am going to take a separate line just to evaluate what g of 3 is. And I would advise you to do likewise because I find people try to do too many steps at once and then they mess it up. Let's see, g of 3 equals 6. So it isn't f prime of 3 times 6, it's f prime of 6 is what we need to go after. And let's grab g prime of 3 would be the 2, wouldn't it? Multiplied by 2. Now my final, well, probably not my final line, but my next line is going to be looking for f prime. What is f prime of 6? Well, f prime of 6 turns out to be 5 multiplied by 2 gets me an answer of 10. Aren't those fun? I like them. Anything that you didn't understand there? Okay, part A has another part within it. It says write an equation for the tangent line of h at x equals 3. Well, we are getting darn good with with writing equations of tangent lines. We know we need two things. We need a point. So when x is 3, what is y? And we need a slope. F prime of 3 turned out to be 10. So we've already calculated that. What I don't know is what h of 3 was. So let's do a little bit of work and find h of 3. H of 3 is going to be f of g of 3, right? I got to go back to how h was defined. H of 3 would be f g of 3. G of 3 was 6. Now what's f of 6? F of 6 is 4. Okay, so when I put in 3, I get out 4. I've got my point. I've got the slope. We can write an equation of tangent line. Y minus the y value equals the slope times x minus the x value. Ooh, tend to not turn out so 10-ish, did it? And you may leave your answer in that form. I'm happy with that. All right, on to part B. Try to not make this lesson so long in recording. Part B. J of x. J of x is defined as g of f. So let's do j of x equals, we can do the derivative. J prime of x is equal to g prime, derivative of the outer, leave the inside, because it's evaluated at u, isn't it? And then times u prime, which in this case is f prime. We want to evaluate all this happening at 2, so I should indicate 2. J prime of 2 turns out to be g prime of f of 2 times f prime of 2. Go to the table and find your values. Hit pause. I want you to find them in the table by yourself. Okay, f of 2. F of 2 is 2. Well, that's kind of unfortunate. And f prime of 2 is negative 2. Are those the values you came up with? Final step, I need to know g prime of 2. G prime of 2, oh, is 0. So everything's going to zero out on us. We get an answer of 0 here. Or do we? Yeah, we should. My notes are off. I don't know what I did in them. Yeah, I do. I went after G, not G prime. Alrighty, so 0 is our answer. C. Let me grab C. What is C asking us to do? Given K of X equals 1 over G squared. Ooh, I'm going to have to use some rules. You could use quotient rule, or we could rewrite, let's rewrite this with a negative exponent and say K of X equals G of X to the negative 2. So do you see an outer function and an inside function? That means we've got a chain rule, doesn't it? So K prime of X, derivative of the outer function. Negative 2 is our outer function, so negative 2. Leave the inside piece, this is our u, and then raised to the negative 2 minus 1, right? So it would be negative 3 if you want to write that, go right ahead. And then derivative of the inside here is chaining off to get the derivative of the inside. All right, I like the layout. I just need to evaluate now at 3. So K prime of 3 equals negative 2 of G of 3 to the negative third. So that, of course, is going to drop to the denominator. And then I need a G prime of 3. Organizing this, I would have negative 2 times my G prime of 3. Looks like it is 2, doesn't it? All over G of 3 cubed. So that's going to give me a negative 4. I'm going to draw an arrow so you know where that 2 came from. A negative 4 over, what is G of 3? G of 3 is 6 over a 6 cubed. And 6 cubed, just looking to see if I have a similar, yeah, I've got the same answer, I just didn't expand 6 cubed. I think it's 216, which means that this is reducible, but, you know, have fun with that. Go ahead and do it if you want. Next, D. I just want to get through the guts of this. D. Ooh. We got a 4 multiplier. That doesn't bother me, right? We're just going to move 4 out front and then do the derivative of f of 3x squared. All evaluated at 1. These can be challenging. And you know what? With a little bit of practice, you will get very good at these. And that's a great thing because the AP does love to do these. So derivative of the outside function. Outside function is f. Evaluated at the u, or the inside, 3x squared. Chain off, and now the derivative of 3x squared. I'm going to show it so that you know where this 6x is coming from. So I get m prime of x. You know, it never hurts to take more steps. Sometimes it can harm you by taking fewer steps. And this will be a 6x. Okay, now we need to evaluate this stuff at 1, don't we? I'm going to have m prime of 1. Now, if I were doing this by myself, I would go 6 times 1 is 6, times the 4 out front is 24. But I want you to be able to follow my work, so I'm going to take it slowly. This would be a 3 times a 1 squared and a 6 times a 1. So now I'm going to get my 24 f prime of 3 To the table. Whoops, to the table, but I don't need to rewrite that. F prime of 3, F prime of 3 intersects at 7. And whatever 24 times 7 is, it is 168. We get a numeric answer for that, dude. Fantastic. Looks like D was the last on that. So that's using tables. Just think of what your rules would be and follow them. All right. Not so daunting. The next one, we have chain rule using graphical data. Well, I can see that there is a graph for f of x and there's a graph of g of x. And so if I ask, what is f of 2, you would be very easy. It would be very easy to respond, oh, f of 2 is 2. So these identify points, don't they? Put in an input, you get your output. The other thing we can get from these graphs are the slope. I can tell what f prime is along this segment, right? All I have to do is look at the slope of it. So, you know what, oh, what is that, -1? I might just indicate along there that that has a slope of -1. On this other one, looks like up 3 over 1 has a slope of 3. And then along this part of the function, our slope is 0. That might make it faster to do the problems below. All right, so let's go for this. You're going to see very similar type of functions that we used, written out kind of the same as what we did with the tables. It's just we have to use graphs now to get our data. So start in the same spot. H prime of x equals derivative of the outer, leave the inside alone. Are you getting familiar with that saying? Times the derivative of the inside. Chain rule. Next, h prime of 4 would be g prime of f of 4 times f prime of 4. We can get a couple pieces from our table. So to the table, g prime. F of 4, F of 4. It is the point, isn't it? Not the slope. So that would actually give me a 0. And then F prime of 4. F prime of 4, what's the slope along there? It is -1. If you want to indicate, this means the slope at x equals 4. Okay? But you knew that. Next, g prime of 0. Now I've got to go over to the g graph. G prime of 0. I need the slope along this linear function. Looks like it's down 2 over... Oh, no, it's not. It's down 1 over 2. -1/2. So g prime of 0 would be a -1/2. Multiplied by a negative. Looks like our answer, h prime of 4, turns out to be positive 1/2. I like it. If you need to, indicate that this is asking for the slope at x equals 0, right? The slope of g. All right, on to the next one. You want to see if you can do it yourself? Hit pause and then come back. It's good to try it on your own because that's when you learn the most. When you get challenged and have to start thinking on your own, that is when you probably learn the most. Derivative of the outer times the inside times derivative of the inside. Evaluating this at 2. F prime g of 2 times g prime of 2. One is asking for the slope there at the end, and one is asking for the point. Let's work left to right. K prime of 2 equals F prime g of 2. G of 2 is the value -1. G prime of 2 is going to be the slope, isn't it? What's the slope along there? Down 2 over 1. Down 2 over 1. Down 2 over -2. Goodness. So that is multiplied by -2. Now I need f prime of -1. F prime of -1 has the slope of 0, doesn't it? F prime of -1 would have been that location, but the slope is 0. And 0 times anything, of course, is 0. K prime of 2 is 0. I'm coming down with a little bit of a cold, you guys, so sorry. Once in a while, I have to just drink some tea. All right, P of x, g of natural log. Oh, interesting inner function there. We know what the derivative of natural log is, right? The derivative of natural log x is going to be 1 over x. Just, all these things, pulling them from our brain, our memory. P prime of x equals g prime of, leave the inside alone, chain off, derivative of the inside. I'm just going to indicate that we're taking the derivative there. Now, we want to evaluate at 1. I think I can do some of this work. No, I'm not. I lied. G prime of natural log x. And the reason I can't throw 1 in there yet is because I should take the derivative of that first. I can't plug in natural log of 1 here and then expect to take the derivative and get the same thing as natural log of x. They are not the same. So I took the derivative of natural log x and got 1 over x. Now let's throw in our 1. So p prime of 1 will turn out to be g prime of natural log 1, which you should know what that evaluates to, and then 1 over 1. P prime of 1. Okay, now this time you really do have to think, what is natural log of 1? If you don't know it, key it in your calculator right now, and then lock it in your memory. Natural log of 1 equals something. That means I've got e to a power gives me 1. E to something equals 1. E to the 0. Sweet! G prime of 0. Multiplied by 1. Don't need to write a 1. G prime of 0. That was the one that had the slope of -1/2, right? I keep hitting clear all, and that just clears away my stuff. So looks to me like p prime of 1 is -1/2. That was example 12. Ooh, we got a few to go. All right. They just take some time. I don't think they're necessarily hard. They just take some writing time. Oh, we got an e function. Lovely. We are going to take e to the f of x. I didn't want that quite like that. I need to take its derivative. And then I need to take the derivative of f prime of x, right? Derivative of the outer times the derivative of the inner. So the derivative of e to the u. The derivative of e to the u is e to the u times u prime. That is what we're working on with this e to the f of x. So it is itself. It is going to be an e to the f of x times f prime of x times this f prime of x. So this stuff is coming from that. Use some pencils of different colors or pens of different colors and connect those two. Now, we want to evaluate at 3, so let's get to it. L prime of 3 equals E f of 3. I can get that from the graph. F prime of 3, I can get that from the graph. Another f prime of 3, I can get that from the graph. Let's go get our numbers. E raised to the f of 3. F of 3 is 1, so this is going to be an e to the first. I'm going to write it down so you can see where we got that. This has a slope of -1. You probably still have all your slopes showing. -1 times a -1. Looks like our answer is just E. Haha. And I'm asking myself, ew, I'm sorry, you guys. I muffed this one. I ended up doing chain rule twice on this, and you probably were catching me. You know what? This little extra should all be erased. Because I then did it, I kind of restarted. This was what I needed to take the derivative of, wasn't it? Not times another f prime of x. So here is the chain rule following through. I got the chain rule right there. So if you would, I am so sorry, you could get rid of all of those extra pieces at the end. So it looks like we are actually going to end up with negative e. Yeah, I'm sorry. It pays to go back and look over your work, and I just happened to notice I did the chain rule twice. Darn it! We even make mistakes when we're been teaching it 8-9 years. Alrighty. B of x. We want to get to b prime. So b prime of x is going to be derivative of the outer. I need to take the derivative of sine g of x, and then take and chain rule g prime of x, right? So what is the derivative of sine? It is cosine. So this will become the cosine evaluated at g of x times g prime of x. Didn't do the chain rule twice this time. Now, b prime of 2. Cosine of g of 2, g prime of 2. I'm kind of hoping this turns out to be a nice number, g of 2, because there's only a few values that I know the cosine for, and those are the values on the unit circle. So let's see what this turns out to be. G of 2. G of 2 is a negative 1. I can do negative 1. Cosine. Oh, cosine of negative 1. No, I can't. Cosine inverse of negative 1 I can do. G prime of 2. G prime of 2 is asking for the slope along here. That's a down 2 over 1. That is a negative 2 slope. And we are going to leave our answer as negative 2 cosine of negative 1. Yeah. This is an okay domain value. That's fine. I just don't know the value of it. You could get it in your calculator. All right, but not necessary. So, next one. F of cosine. Derivative of the outer, right? Q prime of x. Derivative of the outer will be an f prime of cosine x times derivative of cosine x. And the derivative of cosine x, use a parenthesis so it doesn't look like you're just simply subtracting sine x. Now, we want to evaluate at 0. So this will be q prime of 0 equals f prime of cosine of 0. That one I can do in my head. Minus sine of 0. That one we also know. So we just got to go after some of our common unit circle values. Cosine of 0. Unit circle sits over here. Cosine of 0 is 1. Sine of 0 is 0, so I'd have times 0. F of 1 is defined. Ooh, f prime of 1 is not defined, is it? It hits at a sharp point. Which means that is undefined. So this is going to be q prime of 0 equals undefined. Good to see one like that. Alrighty, I'm going to erase my ink because I can tell my machine is slowing down a bit. And the less ink I have in place, the faster it processes. Oopsie, one too far. We got those last two to go, and then we're done. Okay, r of x. Oh, it's a natural log one. Natural log derivative 1 over u times u prime. That's what's in our head, right? So, r prime of x. Derivative of the outer is going to be a 1 over g of x. 1 over u. This is our u, remember. Chain off, and the derivative of u would be g prime of x. And that's all it's to it. R prime of negative 1 equals 1 over g of negative 1 times g prime of negative 1. G of negative 1 comes out with 2. Well, so this is a 1 over 2. And then The slope at -1 for g is -1/2. Oh, I put it in the wrong spot. I already had the parentheses set up. My eraser's just not connecting. Looks like we get -1/4 on our answer. I'll extend it here. -1/4. R prime of 1. Of -1. All right. Lastly, a g of e of the x. Erasing that. D prime of x. What is the game plan in your head? Derivative of the outer times derivative of the inner. Okay, derivative of the outer evaluated at the inside times derivative of the inside. I'm just going to indicate that like that. Let's get to it. D prime of x. I cannot put 1 in yet because then I'd have e to the 1 taking the derivative of that. And that would just wipe it away because it would be derivative of a constant. Instead, I need to think, what is the derivative of e to the x? It's e to the x. Now I'm ready to evaluate at 1. G prime of e to the first. Oh, that's going to be fun. E to the first. So d prime, okay, you're probably asking yourself, what the heck? G prime of e to the 1. Where's e? G prime of, you know what? I'm thinking in my head about 2.718 times e. So G prime e is 2.7-ish. Somewhere along this line, the slope along that line is -2. So I can do this problem. You would have thought it would have been difficult. D prime of 1. Let's give ourselves a reminder that this was the slope at E, which is about 2.718. And that was, then we could look it up on the graph. All right. I hope you like those as much as I do because you get some experience here on this worksheet. Yeah, you get to do 9 of the ones with the table and a few more on the back using a table. So probably 9, 10 of those again. All right. They are very important because you will see those often. Have a great day.